So here's another example of a z and w value where you're asked to multiply z times w and then divide z divided by w. The difference with this problem is z and w are given to you in rectangular coordinates, so you need to first convert them to polar coordinates to be able to multiply and divide them. So that's what we're going to do here. First, let's take z and convert it to polar coordinates. Z equals 10 plus 10i. So if we plot this, we see that z is going to be in quadrant 1 because both x and y are positive. So if we assign our values, if this is 10 and this is 10, then we know through the Pythagorean theorem, or just from recognizing, that this is going to be 10 root 2. And since the two side lengths are the same, we know that this angle, the reference angle, is 45 degrees. And since it's in quadrant 1, the reference angle is the overall angle. So we know that our r is 10 root 2, and our theta is 45 degrees. So in polar form, z is going to be equal to 10 root 2 cosine 45 plus I sine 45. Okay, so now we need to find w. I'm going to run out of room here. We'll do w up here. W equals, we'll do our grid, we'll plot these points. W. Okay, so if w is root 3 minus I, that's going to put us in quadrant 4. So if we draw our triangle, we know our x value is root 3, our y value is negative 1. So again, if you recognize this as a 30, 60, 90 triangle, then you know that this hypotenuse is 2, and this reference angle here is going to be 30 degrees. If not, you can always do the inverse tangent and the Pythagorean theorem to find those two values. Now that we know those two values, we can determine our theta. Overall theta is going to be this angle. So theta is going to be 360 degrees minus 30 degrees, which is 330 degrees. So now our r we've just determined is also 2. So our z value, this equation in polar form, is going to be z equals 2 times cosine 330 plus I sine 330. So now we have the two equations in polar form. So now that we have them in polar form, we can multiply them and divide them. So we're going to say z w is going to be, whoops, I was calling that z and it's supposed to be w. This should be w. Okay. So we're going to multiply the two r values. So 10 root 2, don't know what that means, hold on. Okay, now that we got that out of the way, we're going to multiply the two r values. So 10 root 2 times 2, so that's going to be 20 root 2, and then we're going to say cosine, and we're going to add the two angles together. So we're going to have 330 plus 45, which is 375, plus I sine 375. Okay, and if you see that 375 is more than 360 degrees, it's basically a full rotation of 360, and then you're going back into quadrant 1 a little bit. Do you see that? We've got, start at 0, we go all the way around and we hit 360 here, so 375 is a little bit more into 360. I mean, a little bit more than 360. So do you see that if we take 375 and subtract 360, we'll land in the same place, but we're just one rotation less, so it's a simpler number? So 375 minus 360 is the same thing as 15 degrees. So we can rewrite this to simplify it as ZW equals 20 root 2 cosine 15 plus I sine 15. And that's the most simplified way to write Z times W. Now again, if we want to divide Z divided by W, we say Z, the R for Z, which is 10 root 2, divided by the R for W, which is 2, times cosine, and we're going to subtract them, so we're going to say 330 minus 45, which is 285, plus I sine 285. And if we simplify this one step further, we get 5 root 2 cosine 285, whoops, plus I sine 285. That is about as simplified as you can get to multiply and divide two complex numbers in polar form. I hope that this helps.